Hello, my name is Brian Penfound, and today I want to talk about Explain the Method, which is an assignment that I use for pre-service teachers. And specifically, Explain the Method is using video assignments to explain specific scenarios in mathematics. To give you an idea of where the presentation is going to go, I'll talk about first creation. So this is kind of looking at my course overall, giving you an idea of what a usual breakdown is and how I came up with the idea of the Explain the Method assignment. In the second portion, we'll take a look at implementation. This means we'll view what the assignment looks like and what the expectations are for students. In the third portion, we'll take a look at some of the outcomes. So we'll take a look at how my students viewed the Explain the Method assignment, and we'll take a look at some student exemplars as well. And then finally, I want to talk a little bit about some of the struggles from implementation of this specific assignment in my pre-service teaching class. My position at the University of Winnipeg is a joint position with both the Math and Stats Department and the Faculty of Education. As such, I teach math content courses to pre-service teachers to satisfy their math requirement for their degrees. For these specific math courses, a typical mark breakdown might look like this. I generally have about 50% allocated to the final examination in this course, and I have typically 15 to 20% for each of the term tests. I prefer to have 2 term tests throughout our semester. And if you add this up, we have 90% or so far, and that leaves us with this extra 10%. And so my question was, what should I do with this extra 10% and what should it look like? So let's take a look at what we typically do with this last 10% in mathematics courses. We might fill this last 10% with quizzes. Carey, in his book, How We Learn, discusses storage and retrieval strength. Each memory that we have in our long-term memory storage has both storage and retrieval strength. Storage strength refers to how well this memory is learned, and retrieval strength refers to how easy we have access to this memory inside of our long-term memory store. It's been shown that assessments such as quizzes that ask for fact recall increase both storage and retrieval strength of those particular memories that we would like our students to have in their long-term memory store. However, if I do decide to allocate this last 10% to quizzes, then my full breakdown is 100% testing. And I already have a final exam and 2 term tests that are high in fact recall that are going to help with storage and retrieval strength. So something else we might consider to do with this last 10% is something along the lines of group work or written assignments. However, Tom Bennett, in a very popular article in the TES, discusses how group work tends to lead to disguised inactivity, or students who look like they're doing work but actually aren't doing anything at all. Group work can also lead to something we call unequal loading. This means that specific students might be doing more inside of the group compared to other students. And essentially what happens in these environments is we get unfair assessment. Some student is doing more work than a different student, yet they're both obtaining the same final grade. So I tend to not use group work or written assignments for first-year mathematics courses. So is it possible for us to fill in this last 10% with something else? And what is that something else? What does it look like? To give you a bit more background of what I do at the University of Winnipeg, I've created some videos for some of our foundational skills courses. So we have 2 courses that are called Math Access courses. And I've flipped those Math Access courses and I've created online instructional videos for both of these courses. I've also flipped our Linear Algebra 1 class, and flipped class is where students will watch online instructional materials before coming to class, and then while they're in class I have them work through some more examples together in small groups. This gives me an opportunity to walk around and help the students out with whatever they might be struggling with. And currently I'm creating an online pre-calculus review webpage for the Math and Stats department. So having this background, I asked myself the question, is it possible to use videos in this last 10%? And what would a video assignment look like? And over here on the right, you can see a picture of my YouTube page. Feel free to go check it out. It's Brian Penn Center. Currently, I have videos for Math Access, for Pre-Calculus, for Linear Algebra 1, and for Linear Algebra 2. And I'm intending to make some more videos in the coming years. So let's move into the implementation. What does the Explain the Method assignment look like? Last semester, I had students submit 2 video assignments. They were about 5 to 7 minutes long, and I weighted them as 5% each. The students had 3 choices for each of their video submissions, and I only required them to do one of these choices per submission. The core essence of the assignment was to take an algorithm and explain the mathematics behind the algorithm, as well as evaluate an example that goes hand in hand with the algorithm. It seems as though the second part might not be that important, but actually it was quite important. For example, one of the Explain the Method choices was to explain why a negative number times a negative number is a positive number, and then to evaluate a multiplication of 2 negative numbers. Some students were able to explain the mathematics behind the algorithm fairly well, but when they went to evaluate the example, they did something like this. They said, well, negative 7 times negative 2 is positive 14. So essentially what they were doing was viewing each of the digits of the negative number as a negative number itself, and assuming that this multiplication gives a positive value. So this is a major misconception that I found by having them evaluate a specific example that tied hand in hand with the mathematics they were explaining. I allocated the marks of the assignment to 3 places in particular. The first one to clarity, how well they can explain the mathematics behind the algorithm. The second part to correctness, were they correct in their explanation and the evaluation of the example that went with their algorithm. And the last part was efficiency. Did they explain the algorithm well, or were they bouncing around or using several unnecessary examples? Because this was a math content course, I wasn't necessarily looking at things like style or pedagogy. I didn't care whether or not they had good teacher voices, for example, if they said or whether or not they were using an app on their tablet, or whether or not they were standing at a blackboard explaining. None of that was taken into consideration for the assignments. So to give you an idea of what one of the ETM assignments might look like, here are 3 examples. In the first example, I was asking students to explain why a negative times a negative is a positive number, and then evaluate this multiplication of 2 negative numbers. In the second example, I was asking students to explain why we shift the decimal in the divisor and the dividend when we're dividing decimal numbers. And in the third submission, I'm asking students to explain the procedure for multiplication of decimal numbers. Why is it that we remove the decimals and then add it in at the end, and how does that work? So how did the students view the ETM assignment? Well, I asked a poll at the end of the semester. I only got 9 responses, which is about 1/4 of my class, so I'm not able to give a lot of feedback about this, but at least I know that about 1/4 of my class didn't hate my ETM assignment, so that's very good news. And in fact, you'll see that the 9 that did respond actually liked them, or agreed that they were okay. So that is indeed nice feedback to get from my students. Next, what I'd like to do is give you 2 exemplars of student-submitted ETMs. The first one is from a student from my particular mathematics class, and she is going to explain the concept of equivalent fractions.
Starting with 1/4. Let's just multiply the numerator by 3. What we get is 3/4, which has the same number and size of pieces. There are just more of them colored in, creating a bigger fraction. But what happens if we multiply the denominator by 3? The resulting fraction is 1/12, which is much smaller because even though the number of pieces colored in stay the same, the pieces got a lot smaller. How does this relate to equivalent fractions? Well, when you think about it, an equivalent fraction is when you have more pieces colored in, but the size of those pieces is small enough that the overall amount colored in stays the same. As we saw above, when we increase the numerator, we increase the number of pieces colored in, and increasing the denominator decreases the size of those pieces. So it makes sense that if both of these things happen at the same time and at the same rate, the result will be an equivalent fraction.
The second exemplar I'd like to show you is not from my mathematics class, but from the mathematics class of one of my colleagues who took the ETM assignment and reworked it for her class. In the particular ETM that she wanted submitted, she asked the following question. John had a chocolate bar. He gave 4/5 to his brother. His brother gave 5/8 of his piece to his sister. What fraction of John's original chocolate bar did the sister receive? So here the student is going to show you how to solve this example using Cuisenaire rods. After she was done doing this, she did go on to show algebraically how we can utilize multiplication of fractions to answer this question. And in my opinion, that's what makes this particular submission very good. She ties that concrete representation into working arithmetically with the fractions at hand.
So the orange rod up here is going to be the whole, and we have found 5 red rods that are equal in size that represent 5/5, the same as the whole. John gave 4/5 of the chocolate bar to his brother, so we are going to take 4 of the 5 pieces and identify those as the pieces that are going to his brother. So we have a new whole, 4 equal pieces of the chocolate bar. We will identify this new whole using the brown Cuisenaire rod. In the next step, we find that the brother gives 5/8 of his piece to his sister. So looking at the new whole, the brown rod, we have to divide it into 8 equal pieces, into eighths. So we find 8 cubes that, when put together, are equivalent to the whole. Of these 8 cubes, 5 will go to the sister. We need to take the 5/8 that she received from one brother and compare it back to our original whole, John's chocolate bar. To verify that the sister receives half of John's chocolate bar, we take 2 yellow Cuisenaire rods, which make up 1 whole of John's original chocolate bar, showing that she indeed did receive half of John's chocolate bar.
Finally, the last thing I'd like to discuss briefly with you are some of the struggles I had with my first semester of the ETM assignments. At the University of Winnipeg, we use Desire to Learn a Nexus space. That Nexus page comes with a Dropbox that the students can use to submit assignments. A lot of my students use iPhones and use their iPhones to record the videos. Something about recording videos on the iPhones creates these really large files, and when all of the students try to upload those really large files at the same time when the assignment is due, you end up with a lot of troubles, and students end up emailing you saying they can't upload things. it becomes a real nightmare and a real mess. So one thing to consider if you do want to do an assignment like this is make sure that you have a reliable place for students to upload those videos to you, or better yet, have them download them onto a USB and just collect all of the USBs. For me, when I did this the first semester, I found that students had too much choice with their ETMs, which made it a bit more difficult for me to mark. So this semester I recently did the ETM assignment one more time with fewer choices. So I've done 3 submissions with 2 choices each instead. These are a bit easier to mark since I only have to compare and contrast videos for 2 choices rather than 3 choices. And the last thing that I really struggled with was the fact that I am just a really easy marker. So it turned out that during this first semester, the ETM assignments really pumped up the grades of my students who submitted them. In other words, I don't think that my grades necessarily reflected how well or poorly they did on their ETM assignment. So I was too much of a nice guy, and I need to be a bit more of an ass the next time that I do the ETM assignment. So I just want to say thank you for taking the time to watch my presentation, and if you do want to take a look at some of the references that I did make throughout the assignment, they are here for you. And of course, if you have any further questions, you are more than welcome to chat at me on Twitter @BrianPenfound, and I'll be more than happy to answer any of your questions.